you hear people talking about the GMO being, we don't have capacity or it's a Western technology, it's a new thing, you wonder because this lab was commissioned in 2005. That is 18 years ago. And over the years, we have been doing this research in this country. And many colleagues who are experts in GMO development have passed through this lab. Well, I think we've had so many discussions and so many definitions around GMO, but basically, if I have to speak to our intended end users, a genetically modified organism, which is the GMO, is just any organism that has received or a gene from another organism that belongs to a different species that naturally cannot mate. Well, it's a long process. To start off, for you to successfully develop a genetically modified organism, averagely you take between 12 to 15 years. And it starts from the conceptualization of the whole idea. We just don't wake up in the morning and say we are making a GMO. For what reason? There must be motivation. So you conceptualize an idea, and for you to successfully conceptualize that idea, there must be need. So for instance, in this country, we would say we have a problem with drought, okay, in the face of climate change. So when that happens, as molecular scientist or a genetic engineer sits down and says, what can I do? Then the thinking would be, we therefore would require our plants that are tolerant to drought, isn't it? And then how do you start? You think about, are there already plants out there that are tolerant to drought? Then when you realize that yes, there is, then you go and study that particular plant. Say, for instance, we can say sisal. It will withstand a lot of drought, more than, say, maize. So we go to sisal. Then we start understanding, because now, with the emerging trend in terms of sequencing, you sequence the entire genome of the sisal and get to know what are the genes that are responsible for making it drought tolerant. And just for this discussion, you might realize that the roots are deeper than the ones for the maize, or the leaves, which are now thicker, and cuticle are shiny, so it reflects back the heat. So you'd imagine those are two nice traits that maize does not have. I hear a lot about the chemicals. And when there is a reason why it's not chemically modified organisms. If people feel that the concern is the chemical, then we change the name from genetically modified organism to chemically modified organisms. Anytime we talk about the gene, we are talking about the DNA. So we are only modifying the DNA for traits that we want. Anything that has a genome and has a DNA is alterable. We can ensure that we identify sections that are critical, and it can be excised very well and be used and transferred to another organism. It's quite different. When you talk about genetically modified organism, I said, is that you pick the DNA from a source that naturally doesn't cross. Even in plants, maize, for instance, you hear a lot of hybrids. Hybrids are not GMO. They are just one maize here that seems to be taller, another one here that seems to be shorter, but it's drought tolerant. Then you just pollinate them so that you get a bit of the shortness, drought tolerance, and a bit of the height for improving food production. So people do cross. The moment you thought about crossbreeding, because you find something in this that is not in this, and yet there's something in the other one that is not in this. And if they belong to the same species, you can cross them. So when you look at all these things and how it happened, you can see this is now sorghum happening. You will see a lot of it being protected here, of course for birds and also for pollination. If you look at the maize, you will realize that the maize, you cover the cob and you also cover the tassel, you see. So this is labeled and it was pollinated. So when you do that, it becomes maize, and now you can harvest this. And this is for bulking and also for knowing what is the pedigree. Because now we know the source of the pollen, and whatever is in there is now pure because you have controlled its pollination, and therefore you can do some known research around it. So it's just maize like any other. And this is what we do naturally. And some of these things that we do also happen naturally. So if you want to self or you want to cross, so if it is crossing, we put, we take the pollen from another maize and then we come, we pollen this. If we are selfing, we pick its own pollen and then use it for, pollination. So you can do cross-pollination or selfing. All these are things that we do around here for purposes of addressing particular traits that we are interested in. A GMO, and I keep repeating this, is not the silver bullet. It is not a solution, the only solution. It is a complementary approach. We are saying that if I make GMO that is drought tolerant, maize that is drought tolerant, the problem that has been solved is just the water bit. So the whole process of genetic engineering is complementary to existing technology. We still would want the government and stakeholders to make sure that the value chain for the farming system is still optimized. And then we are good to go as a country.
Thank you so much for keeping it here. That is all we had for you today. See you on the next one.